I think I'll start now. Again, thank you for joining our webinar, which you may have received invitation from your local Beckman Coulter sales rep. Our speaker today will be Mr. Bill Bars. He's a senior application scientist in our Oregon office. He's been with the company for 24 years in the liquid particle counting department. He will speak today on the ACFTD calibration discontinuance and how it affects our Hayek liquid particle counters, the 8011 and the pods. Just a housekeeping note, to allow attendees to ask questions during the presentation, please mute your phone to minimize unnecessary background noise. Would that be appreciated? Thank you. So with that, Bill, if you'd like to start.
You bet. Thank you, Leiko. Good morning. This is Bill Bars. Again, today we're going to be talking briefly about the ACFTD discontinuance and how it affects our Hayek users and customers, specifically the 811 Plus and the PODS Plus. So throughout the course of this webinar, if you do have questions, feel free to chime in, and we'll try to get those answered at the very end of the presentation. Also, there'll be a Q&A session for those that have additional questions. So without any further ado, we'll just jump into it. So, what to do now that ACFTD is discontinued. So our target date is going to be the end of this year for our commercial users. For those of you that don't know what ACFTD is, the background is air cleaner, fine test dust, ACFTD, was used by the hydraulics industry as a calibration medium for petroleum-based liquid particle counters for many years. It came into existence, back in the 60s. It was used, in the 70s and 80s. And then we got into the 90s, and that's when ISO medium test dust came into effect in 1999. So it's now been 20 years that we've actually had a calibration media that's traceable to NIST. And so we're trying to transition some of our customers that still maintain the AC fine test dust calibrations into the new more modern calibration method of ISO medium test dust. So ACFTD, again, outdated calibration media. It was initially manufactured back by AC Rochester or AC Delco back in 1992. Even though ACFTD was the media of choice, because that's what we had, it was not traceable. It was characterized initially by a gentleman by the name of Kernbauer, and we've come to find out later on that the original characterization wasn't as accurate as they originally had thought, but now with the advent of new modern equipment, technologies, and techniques, they have since characterized it, and they realized that it's no longer being processed or produced. And so today we have ISO medium test dust that is NIST traceable, and so that's what we're trying to do is transition those customers that have the old calibrations and report out to the old standards like NAS 1638 and also the NAVAIR standards, which report out those old ACFTD, what I call sizes of 5, 10, 15, 20, 25, 30, up 50, up to 100. Trusted supplies of ACFTD are extremely limited. We still have some. There's a couple of manufacturers out there that still have some, but they are very limited. It was replaced by medium test dust in 99, as I mentioned before. And the really nice thing for the new Hayek 811 Plus and the PODS Plus, we can actually report out to the legacy reporting standards of NAS 1638 or the NAVAIR standard, even with the medium test dust calibrations. Inside of the software, the application, there's an algorithm that normalizes the AC fine test dust sizes to the medium test dust sizes. So we're able to accurately report out even those old NAS standards with a new modern traceable calibration. Why are the sizes correlated differently? This is a question I answer frequently, and it's really based upon the sizing methodology. So back in the day, the old ACFTD sizes were based upon what we call the longest chord method. And basically that's the longest dimension of a particle as it goes through the view volume. If it's the elongated, like a little stick that goes through there and it's 1 micron by 5 micron, it would be sized as a 5 micron because that's the longest dimension. In today's modern sizing methodology with the medium test dust, it's actually uses the projected area method, which takes that elongated particle, if it is shaped like that, and basically takes the total volume of that and makes it into a circle. So it would actually be sized slightly smaller than the 5-micron longest dimension. And so that's the fundamental difference between the two sizing methodologies, and that's why we have correlation charts, et cetera. So if you look at this, the old 2-micron is now sized as about 4.6 micron if you look at the center of this picture. But for the NIST sizing, it's actually sized as a 4, and so on and so forth. 5-micron is actually around 6.4, being sized MTD, is reported as 6 micron, et cetera. So that is the fundamental reason why, we have to correlate the old sizes to the new, and that's with the sizing methodologies of longest chord versus projected area, why they don't match up number for number. So, isomedium test dust, it's the world's preferred calibration media. It's available and reproducible. It is a NIST traceable calibration media rather. The medium test dust calibration is first introduced 20 years ago with the first release of the ISO 11171 standard. The 11171 standard is a calibration standard that can be used across the world, and if it's adhered to verbatim, then it doesn't matter who the manufacturer is of a particle counter, as long as they're using the right calibration media and all the annexes within the standard, you're pretty much going to get a particle counter that's going to read out. They're going to track pretty closely, even by different manufacturers, as long as they adhere to the standard. That's why it's so crucial to transition folks from the old AC fine test dust calibrations to the new modern calibration, just so we have, basically tracking and traceability and comparability across manufacturers, but also even within our own product offerings. With the Hayek, the modern instruments support the MTD calibrations. Again, with the 11 Plus and the POS Plus, we can actually report out to the old NAS 1638 standards and the NAVAIR standards. And of course, as always, we have global service with our products, and so we can actually offer on-site calibration at your facility, where we can come and you don't have to send your instrument in. We can come on site, perform the calibration. We're going to be in and out of there in a couple hours, generally. So we're extending the discontinuance of this calibration, of the AC fine test dust calibrations, till the end of this year. Beyond that, we're going to be offering isomedium test dust calibrations for the commercial products. Contracts apparently won't be renewed for service past that date. Both our field and depot service can continue to offer AC fine up until, again, the end of this year. And it may require hardware updates to transition to the isomedium test dust calibrations, and that's one of the things I'm going to talk about further on in this presentation. How does this affect our old customers? What do they need to do to change their equipment, upgrade their equipment to be able to accommodate the new medium test dust calibration? Okay. So again, what's now? I'm going to cycle back real quick. This is an application note that was written by Mr. Matt Harrell out of our UK office, and I collaborated with him on it and helped him get it published. But bottom line is, this application note will be available to anybody who would like to see it. So at the end of it, I'm going to provide my email address. And so if you would like to have a copy of this application note, and I think there's another one that I referenced later on in the presentation, just send me a quick email, and I'll be happy to fire it off to you. So this is another portion of this application note. And so it basically talks about what are we going to do for our customers? How are we going to support our existing customers that have some of the legacy equipment, that want to transition up to the new equipment and still report out to the old reporting standards. And so here is the upgrade path, solutions if necessary. So on the far left, if you have an 8011 system, not a plus, but an 8011 system with an HR LD100 sensor that utilizes the air cleaner fine test dust calibration, the upgrade path would be to an 8011 plus with an HR LD100 sensor and the medium test dust calibration, and then of course we could report out to the old NAS standards with that configuration. If you have an 8011 plus, this is the next one in transition. If you have an 8011 plus with an HR LD400 sensor utilizing the ACFTD cal, then simply you have to just change the sensor to an HR LD100 sensor, have it calibrated with medium test dust, and then again we can report out to the old legacy standards with that configuration. If you have, in the third option, an 811 Plus with an HR LD400 MTD cal, which you really shouldn't have one, but some of the old, way old HR LD400s had a little bit better sensitivity than the new ones when we transitioned to the new laser diode. The bottom line is if you have this, so the MTD is not supported on the HR LD400, we just simply have to upgrade the sensor to an HR LD100 sensor, and then everything, it would be good to go from that point on. If you have an 811, in the last scenario, 811 Plus with a 400 sensor or a 100 sensor with a PSL cal, you don't need any changes. So it really affects any customer that has an HRLD 400 sensor with an AC fine test dust cal. Then we can upgrade you to the 100, perform the new calibration, and then you're basically good to report out any reporting standard that you wish to do so. So here's the Hayek Solutions, the 811 Plus and the PODS Plus. Analyze reports particle contamination. As we all know, reports are based on cleanliness codes or the custom reporting standards. And with these two instruments, of course, you can print, export, and or archive the report after each run. And again, if you have any questions at all, please feel free to just jump in and ask away, and we'll try to get those answered for you. So this is just a real fundamental comparison between the two Hayek offerings, the PODS Plus and 811 Plus. The fluid compatibility are going to be the same. One's designed for the lab, one's designed for the field. The PODS Plus has online capability. As far as the web server application, that is, the 811 Plus has the web server application, so you can actually bundle data after a run on the 811 Plus and then access it from a remote instrument. Interchangeable sensors to accommodate what your sizing needs are for the 811 Plus, but not the PODS. Vacuum degas capability, again, the 811 has that where the PODS does not. It has twice the sample volume. Submicron capability, the 811 Plus does if you purchase the MC05 sensor. And usually those are for water applications, not industrial, but there are some occasions where customers ask for that. And the magnetic stir capability is available on the 811, where it is not on the PODS Plus. Due to the fundamental design characteristics of the PODS versus the 811. One is the lab instrument, designed specifically for lab needs, as opposed to the PODS Plus, which is a very rugged, quick, dirty, get it out in the field, get a quick indication of what's going on with your fluid, and so the design characteristics, and that's why we've got this chart that kind of should define some of the differentiating characteristics. These instruments with the user interface are unbelievably easy to use, and they're very intuitive. They step you through very quickly how to prepare a sample. Then you analyze the sample, and then reporting out the data. You have modern report out capabilities with exporting data electronically, and or you can print it at the time of use. And again, with the 811, you have web server capability. So one-button testing, no training or expertise required. Again, ease of use. So these are new features where if you have some of the old, this will be more appropriate for customers that have existing equipment. The new 811 Plus and PODS Plus, the automated flow control. There's no readjustment of, pressure regulators to accommodate thinner or thicker fluids. The flow accuracy is, around 0.1%, very, very solid. Again, intuitive keypad operation and the user interface is very simple. You can create custom sample recipes, and you can create custom reporting standards. So if the canned reporting standards that are available with the instrument when you buy it, like ISO 14406 or NAS or SAE or NAVAIR or GHOST, as I think there's an ASTM standard in there. If you need some other channel sizes, then it's very simple to create a custom reporting standard within the application, and it will actually determine via explaining interpolation what the threshold value is for your particular size. If you need an interim size in between, say, 4 and 6, just for your own edification, you're able to do that, and the instrument itself will provide that for you automatically internally. So if you have multiple systems and you create a custom recipe on one, it's a very simple matter to export that to a USB stick and take it over and deploy it to your additional systems without having to go rewrite it at each station. The custom reporting channels, if you want to just report, again, to a custom reporting standard, the PODS Plus allows up to 9, where the 811 Plus allows you up to 18 individual channel sizes. And the precision cleaning, this is kind of a nice tool for our customers. It's kind of an automated walk-away cleaning routine where you can set it up to clean by a particular count on a channel size. Say, for instance, if 6 micron is a critical size for you, that you must have less than a certain amount of counts on that channel before you can consider the system clean. You simply set it up to say 6 micron, less than 10 counts, and you put in a cleaning solution, hit start, and it'll continue to flush until those counts get below that threshold, and then it'll stop. Or if you just want to clean by a certain volume, say I just want to flush it with 100 mils of fluid, you put the new fluid on there, put clean by volume. It tells you what flow rate, or asks you what flow rate, and it asks you for what volume. You program that in, hit the button, and walk away. So 2 excellent features there. Again, as far as the simplicity of using the instrument, as always, preparing the sample fluid before you actually analyze it is the #1 contributor to good, repeatable, and accurate results or faulty results. If you're not preparing your sample properly, then you're basically introducing error right into the analysis. So it's very fundamental where you take your sample, you make sure you drop from the correct position on your system, you agitate it to get those particles in suspension. You then do a degas function to get the air out, because air in particle counters actually shows up as particles because it blocks light through the laser. So preparing the sample properly, you agitate it, you degas it, and then you quickly run it. You do not want any time to go by between those 3 steps. In this case, gravity is not our friend. If there's metal particles, heavier particles, those will drop out of suspension fairly quickly. And so we want to make sure that we have an efficient process so we don't lose those particles out of suspension. Once your prep is done, again, agitation, degas, and then introduce the sample bottle to the system, push the button, let it run a sample, and then at the end of it, you can report it, you can archive it, you can print it, you can export it, all available on either one of the 2 instruments. Benefits, kind of self-evident, saving operator time with custom sample recipes. You can generally get your results in under 60 seconds. Move from one online sampling point to another. So if you have the PODS Plus and you want to just simply take it from point to point on a dynamic system, pretty simple. One-button testing. Again, no training or instrument expertise required. On-site instant reports to eliminate the lab wait times and lab fees. This is a big one for our customers, because it's very difficult. If you're taking a sample and you send it off to a lab, and it may take 1 to 2 weeks to get the result back, but you got a system that's already compromised because the fluid has been overly contaminated due to whatever the reason, ingress of particles from an outside source. Maybe you've got internal breakdown in the system where there's wear metals or things. You want to know that kind of information immediately. You don't want to find out 1 week to 2 weeks down the road because you're destroying your system. You're basically, wearing it out while you're waiting for that sample result to come back from the lab. So, we get a lot of feedback from our customers saying this has saved us a ton on equipment maintenance, lost downtime, revenue, et cetera. Let's see. MultiLiquid testing capabilities. So this is kind of new especially for the PODS Plus, not so much for the 811 Plus, but it's fuels compatible. We can test things all the way down to waters, glycols, and of course the petroleum-based fluids, all the way up to and including 425 centistoke at ambient. Again, we're able to report out to multiple standards from the same sample. Now, this is also a big deal. Let's just say that I run my fluid and I report out in ISO 4406, and then I realize that I need to get that same sample, but I need to report it out in NAS 1638. It's a simple matter to go back into the system, pull up the sample, you key into the area where you're able to change the reporting standard, because when we save the data, we save it in the raw format. So we're able to interpolate it out to NAS 1638, SAE AS4059, ISO 4406. Regardless of how we reported out originally, we can go back in there and ask for that same sample to report out to a different standard. And that's been a big deal for our customers as well, because sometimes they want to see it in both SAE, NADS formats. And with the new PODS Plus, we actually have moisture detection capability that's reported out in relative humidity percent. So that's a new feature for that particular instrument. And it's only true for your oil-based fluids and your fuels. If you run water-based fluid like a glycol or even water through it with a moisture detector, you're going to saturate it. So it's really designed for the industrial fluids and or the fuel oils, diesel, jet fuel, etc. Okay. Both these instruments are equipped with a touch screen, or not a touch screen, sorry, with a keypad as opposed to a touch screen. And the question has come up a couple of times from our customers, hey, why is it not a touch screen? In today's technology, why don't you guys use a touch screen? It's because in the industrial fluid world, it's kind of messy, kind of dirty. These fluids can kind of be, caustic or over time can deteriorate certain materials. And so, we've got a very highly chemical compatible control button screen as opposed to a touch screen, because touch screens typically last 2 to 3 years, and our instruments are designed to last, they're pretty rugged. They're designed to last a minimum of 10 years. So touch screens are difficult to use with gloves and fingers that are wet and oily, et cetera. So we made a conscious decision to do it this way for that purpose. New features, we have some self-diagnostic alerts. So the system itself will kind of do some internal troubleshooting when it sees low fuel, like for instance in the center screen, low fluid pressure, possible causes and actions. So it kind of gives you an idea as you're going through. If it sees a problem, like maybe the fluid is too thick, it's higher viscosity than what the system allows, and it can't regulate the flow, then it'll come up and say, hey, we have low pressure. We have maybe the possibility of the problem, maybe the fluid's too thick, we ran out of fluid. It'll give you some options there, kind of helps you troubleshoot through those issues. And of course the digital workflow, very simple, again, intuitive user interface. Okay, so with 811 Plus, we now have what we call a smart sensor. So a smart sensor has the ability of actually storing up to 4 calibrations in the sensor itself. So if I were to take that sensor and calibrate it on one 811 Plus system, and then I wanted to move that sensor over to another 811 Plus system, it's a simple matter of you basically reconnect it, both fluid and electronically, and when you power it up, it uploads the calibration information from the sensor right into the system. Are they backwards compatible? They are backwards compatible. You just have to have the cable adapter to go back to. So if you have an 811 system and you wanted just to buy a new sensor, even though it's a smart sensor, it's still compatible with your old system. The electronics just would not allow you to upload your calibrations from the sensor to the electronics. You still have to program that in a manual mode. Again, new features for the pods. Does have moisture sensor capability if you so choose. It has an internal pump in it. Those of you that are familiar with the old pods, in order to have portability, you had to have a CO2 cartridge. And they came with 2 or 3 cartridges, but you'd have to have those charged by an external company, charged their 4-ounce CO2, and they'd have to refill those. And that was kind of a nuisance for some of our customers as they tried to find somebody that would refill these cylinders. They weren't always available, especially depending on their demographic, where they're particularly located. So with the new PODS Plus, we actually built in a pump, so full capability, full portability, no CO2 cartridges any longer. That was a big improvement. And then the cleaning routines we talked about earlier. Calibration option reporting standards. So with an MTD calibration, you have ISO-MTD in oil, a full 11171, the PSL and water calibration, and then also the ISO medium test dust in glycol. With the MTD calibration or the 11171 calibrations, you have the full suite of reporting standards that are on the right, the ISO, the NAS, SAE, NAVAIR, GHOST, ASTM, et cetera. So when you have a medium test dust cal or a 11171 cal, you can report out to all of those standards. Here gives you the liquid types that are supported. You know, we have SkyDraw capability, and the seals internally allow you to run all these fluids without any issues whatsoever. So, you know, we got the jet fuels, you have the starter solvent, you know, which is mineral spirit, ethers, alcohols, you know, esters, phosphate esters, et cetera, even, of course, water. So the compatibility capability of these two instruments is pretty phenomenal, considering how far we've come. Okay, so just a quick little note on the PODS Plus. It's got a filter cart mode, and this is a different application note, as I mentioned earlier. So if you'd like to have, I'm not going to go into great depth on this because the whole function of this webinar was based on the ACFTD discontinuance, but this is a new feature for the Hayek PODS Plus. And so it talks about how to connect the system up in the online mode and filter cart mode, where it's important, how to set it up, and then what the benefits are for the user. Some of the support tools we have for these two instruments, you know, online on our Beckman.com website, we have up to 20-plus videos. Unfortunately, my face is in there, and so you have to deal with that, but that's just part of the cost of doing business. Multiple application notes, you know, for anything from how to analyze viscous fluids, you know, running jet fuels, just to name a few. Brochures and spec sheets, you know, we did a really nice job, especially with the PODS Plus, with the new IFU manual. And then, of course, there's overview sheets that kind of talk about individual functionality and why we put that in there, and then, of course, how to engage that with your system. There's a startup guide for the PODS Plus, because if you look at the 811 Plus screen versus the PODS Plus screen, there's enough physical room for us to use text messages or text indications for each one of the buttons in the 811 Plus, where we used icons for the PODS Plus. And so basically the startup guide gives you a map of the icons and what each one of those functions are. Again, very simple. It's all right there. It's encased in plastic because the industrial use that these instruments are or the environment that they're in. So it protects that startup guide with all the icon information. This is the back side of that same document. So just another visual for that. You know, our customer service and tech support isn't second to none. It is a global company, and so we offer global service, you know, for both our customer tech support and, of course, also for the service around the world. So, again, if you have any desire to have either one of those application notes, please just jot down my email address, send me a quick little request, and I'll be happy to send those to you. And now I'll open it up for any questions.
Bill, this is Jim Bursler. Can you explain to everyone about why, in going from the AC Fine Test Dust to the MTD calibration, the size channels are different, and you have to go to an HR LD100 and can't use the 400?
You bet. Thanks, Jim, for that question. That's a great point. So I'm going to cycle back toward the beginning of the presentation, where we kind of show why they're different. We talked about different sizing methodologies, but let me talk just briefly about the reasons why we have to go from an HRLD 400 to a 100. So the 400 sensor was originally designed for ACFTD calibrations. The minimum channel size was 2 micron, but mostly they were calibrated down to 5 micron. That was the first size, reporting size was 5 micron. If you look at the 4 micron channel in relationship, the 4 micron C in relationship to the ACFTD sizes, it was really close to about 1 micron. So the original 400 sensors, or their current 400 sensors, do not have the sensitivity required to perform the MTD calibrations. So what we did when we created the HR LD100 sensor is we optimized the sensitivity of the low end so we can get good resolution down around the 4 micron C, which again equated to about a 1 micron old sizing. And you can kind of see that in this diagram where 4 micron is actually, that channel size is actually smaller than the 2 micron. So it's around 1 micron, a little bit larger. But anyway, we didn't have the sensitivity with the 400, so that's why we created the 100. It has the same flow cell. It's a 400 by 1,000 micron flow cell as far as the aperture size, but the electronics were optimized to accommodate the ISO medium test dust calibrations and that minimum sensitivity. And so that is why we have to specify the HRLD100 sensor going forward. There's no real advantage to have the HRLD400 sensor unless you're doing simply a PSL calibration and you're monitoring something in a water application. But for all industrial calibrations, the HRLD100 is the sensor of choice. Gives you all the performance you need. It allows all the capability for calibration, including medium test dust cals, full 11171 calibrations, etc. Did that answer your question, Jim?
Yes, thank you. And so when would a customer want, you said obviously all industrial applications that are in oils should have the HRLD100, but what would be examples of when they would want a PSL calibration with an HRLD400 with this new standard? Okay.
So really the only application that you want to use an HRLD400 with a PSL calibration would be if you're in a water-only application and you're simply looking at contamination in, maybe you're looking at water, wastewater application, something like that, where you're just looking at particulates in the water. So that gives you a range from 2 micron to 400 micron. We calibrate, I think, from 2 all the way to 300. So we don't have a channel size of 400 because that's the physical limitation of the aperture, but we do provide a calibration point at 300 micron. Again, water applications only, and it would be for, just monitoring water or wastewater. But in the industrial fluids world, the HRLD400 sensor does not give you, it gives you no advantages. In fact, it can't be calibrated with the medium test dust calibration. So it's kind of one of those sensors that's got a niche market now, where it used to be the sensor of choice for AC fine. It's not sensitive enough for MTD/11171 calibrations.
Hey, Bill, it's Andrea. I think
Andrea.
there's hi, thank you for doing this. I think sometimes there are some customers who may use PSL and water for glycols. You can also do a glycol calibration, but I have seen glycol applications use PSL and water.
Yeah, so that is not a desired output because we provide actually a glycol calibration using medium test dust. So we do have a traceable calibration there, even though it's not. It's a traceable medium. It's a traceable calibration. It's for glycol applications because there's a lot of hydraulic glycols that are being used in today's industrial fluid world.
I'm just saying if the customer has a history, they may ask for it, but you're right. It's better to do something different, but that whole industry is a little bit unique, so you have to ask a lot of questions.
Yeah, and you bet. And we run into that typically. When I was in tech support a number of years ago, customers would say, "Hey, I've been getting this PSL cal. I'm running glycols." So it was a customer education point, and so as those calls came in, we would navigate through that, through that application with them. Say, "Hey, we offer an actual traceable calibration now, purposely running glycols," and so we transition them away from those PSL calibrations where they were actually applying that to industrial fluids. It's like, you really can't get there from here. There's no industrial standard that defends you using a PSL cal and reporting out industrial sizes. So yeah, it's kind of a customer education issue. Those are pretty, we've gotten through most of those. They're very few and far between now when they do crop up. Anybody else?
Hi, Bill. This is Ron Turner from Bell Helicopter in Fort Worth, Texas, and I had a question about, for those of us that use our particle counts for buying off military applications for aircraft or aircraft applications.
Sure.
How do we show equivalency between the old ISO 4402, which we're contractually bound to the new ISO MTD test does? How do you propose that we do that we show equivalency?
So when you're talking about the 4402, the channel sizes you're talking about are the old ACFTD sizes, yeah?
That's correct.
And so what we would do, are you reporting out NAS 1638?
No, we're reporting out. I'd have to go back and look particular which ones we're doing, but it's I'm almost positive it's just the standard NavAir format.
Okay, so that's like 5.
The 5, 10, yeah,
25, etc.
Yeah, 50 and 100.
50 and 100. Okay, so we actually have the NavAir standards available in our instrument to report it. Even though it's calibrated with MTD, we can correlate the channel sizes, MTD sizes, to the ACFTD sizes of old, and gives you the NavAir standard in the software. So basically, you can still report out the NavAir standard with an MTD calibration and look at your empirical data versus your new data. And so knowing that we have two different sizing methodologies for the calibration. Remember I talked about earlier in the presentation where we used to do longest chord, and that was the best we had at the time. Now we have projected area. And so you're going to see some differences, but they should track. They should trend very similarly. So in cases like that, what I would encourage customers to do is say, hey, you got years and years and years of empirical data, and now you have a new standard. And so I understand. I don't have the entire answer to your question. What is acceptable to your customer? But we'd be happy to help try to navigate that through with you, and we can explain very simply, scientifically, hey, this is the way it used to be sized. This is how we size it now. Here's the correlation. We understand that we're going to be counting across the board, maybe less counts at each channel size or maybe more counts at each channel size, but it's predictable.
So to follow up a little bit, if we were to purchase a calibration fluid that was the ACFTD calibration fluid from Beckman Coulter, and we were to run that with an HR LD100 using the NavAir spec or the NavAir recipe, would you expect equivalency there? Would we be able to show equivalency that way?
You're saying today you have HRLD400. If you changed them to 100s and then calibrated with AC fine test dust, well, not calibrate it with AC fine test dust, like calibrate it with the standard, the ISO MTD, and then we were to go back and rerun an ACFTD calibration fluid using the NavAir recipe. You're saying there's an algorithm that should compensate for the new standard, if I understood you correctly. It doesn't compensate, but it does report out to the correct legacy sizes.
Okay. Would that show equivalency that way?
Equivalency is kind of a slippery slope. It'll show they'll trend predictably, but as far as you're not going to get the same numbers for the same channel sizes, but you should get. It should be predictable that, hey, this is the way we used to size it. This is the way we size it now. We're going to get maybe within a code, a classification code. We're going to get within a code on each channel size, and if that's acceptable to your customer, then that's how maybe you show quote unquote equivalency. Okay. But we're in a world where we really need to transition to a new, modern, traceable calibration, and for you guys' benefit. When you get you have somebody come in and audit your process, and I'm sure you do, right? Third-party auditors or even customer audits come
exactly.
in. And you have to show traceability. Today, with an AC fine test gust calibration, there's no traceability. There's just, hey, this is our legacy sizes. This is legacy fluid. This is the concentration we've always ran, and this is what we've been getting. So it tracks our empirical results. The downside is okay, but show me your traceability, and that's where the rubber meets the road for a lot of auditors, and you can't do that. And so this transition is, it's not always smooth, but it's very predictable, and we've been doing it with customers for years, and I think we can help navigate you through that process as well.
Would it be possible if I can send you an email with some concerns on some discussions that we've had with our hydraulic engineering here at Bell?
You betcha. No problem.
Okay. Thank you.
Yes, sir. Any other questions? Okay. Well, listen, I would just like to thank everybody who joined us today for this discussion, this webinar. As Lako had mentioned earlier, we are recording it, so if you'd ever like to refer back to it or even, point an associate or colleague or, someone else to that presentation, it will be available. And again, thank you for your time and consideration. I really appreciate it. Lako, do you have any closing comments?
No, thank you very much, Bill. That was very informative, and I hope that it's useful information for all who've joined. And thank you for joining. And again, we will make the recording available. Thank you. Thank you for joining.
Okay.
Thanks, Lako and Bill.
You bet. Thanks, everybody.